Well, welcome to another week. And so today I'm going to be talking about what we did on March 11th. And so let's get right on into it. So the question was, there's going to be a surface, a frictionless surface, and then a plane. And this degree is 25 degrees. And so there's an object that's in motion. So it goes from this frictionless plane or frictionless surface onto this elevated plane. And so when here, the initial velocity is 2.6, and then at its very top, BF is 0 meters per second. And so given this, we were to find the total force of this, actually, was to find the acceleration of the object in this system. And so what we first did was set up the coordinate points. So we were to set up our x and y coordinate planes. And so what we did was we had our y going up this way, and then our x coordinate this way, so our x and y. And so once we set it up like this, we can have, let's set up our free body diagram. We have our F of n, our normal force, going perpendicular to the surface, so right here. And so this is the free body diagram as the object is going up. And so we have F of n. We also have the weight of it going downwards, so mg. And then we also have the kinetic friction force going in that positive x direction. And so with this weight, we know that it's going to have an x and y component. And so given this angle, and since we know the angle has been given to be 25 degrees, we know that there's these two bodies right here. And so this is mg y and mgx. And so now, once we have this, let's sort it into our x and y components. So f net of x equals ma. However, since we know and how we set it up in our coordinate plane, our object isn't moving in a y direction, it's just moving in this x direction. So like right here, it's only moving along here, it's not going up. We know that f net of y actually equals 0 newtons. And so we don't have to worry about what happens in the y direction. That's the entire point of us setting up the coordinate plane, so we can isolate it, we can make it simpler, we can simplify the physics. And so what we have in the x direction, we have what we have here, mgx, so with the weight x, plus the friction force that is going the same positive x direction as we set it up. So the friction force equals ma. And now let's, further derive our formula. It would be mg, it would be sine theta, plus the coefficient of friction, and then it would be times the normal force, so F of n, in the x direction, so F of n x equals ma. So we keep going down, mg sine theta plus this, or it'll be a cosine theta, sorry. Cosine theta equals ma. And so once we have that, we cancel out I forgot to put the mg in front. It would be mg cosine theta equals ma. And just to make sure, our f of n, or our normal force in the x direction, or not in the x direction. Alright, so it would just be f of n, not f of n. I gotta stop saying that. The normal force, it would be mg cosine theta, because the normal force would equal the y component of the weight, and so that would be mg cosine theta. Sorry about that mistake I mentioned earlier. You cancel out all the m's, you get g sine theta plus the coefficient of friction mu g cosine theta equals 8. And so that's our equation for the acceleration, since we don't have to worry about the y component. And so now once we have this, we use the kinematic equation. X squared equals the initial velocity squared plus 2AD. We know that the final velocity in this problem is 0. We know our initial is 2.6 squared plus 2, and we have our acceleration, g sine theta plus coefficient of friction, g cosine theta, and then the distance. And so in order to find the distance traveled, we isolate it. 2.6 squared over 2g sine theta plus 2 mu cosine theta. And then once we have these values, given 25 degrees, their answer should be 0.562 meters. And so that's our final answer. Just to recap and go over everything that we did, we had an object that was initially on a frictionless surface go onto an inclined plane of 25 degrees. We know that the initial velocity as soon as it was on the plane was 2.5 meters per second. And then the final velocity at its highest peak on the plane was 0 meters per second. So now once with this knowledge, we set up the coordinate planes. We set it up to y perpendicular to the surface, x parallel to the surface. And so we set up our free body diagram, our normal force going perpendicular, friction force going against the motion of the object, which is going up in this direction. So the friction force will be opposite of that. And then we have our x and y components of our weight, our x going this direction and y going here. And so the normal force would equal mg in the y direction, which would be mg cosine theta, adjacent angle. And so we would have our acceleration. Now given our acceleration, we can use kinematics because we know the final velocity, we know the initial velocity, and now we're given the acceleration. Plug that into the equation, plug in all our values, and you get an answer of 0.562 meters. And so that's kind of just a combination of everything we've learned so far using free body diagram, Newton's second law, kinematics, and just plugging it all together. I think this is a very good question to test your knowledge of general knowledge of everything we've learned so far. And so that's all I have for today. I appreciate you guys, and I'll see you for March 13th.